In this tutorial we're going to talk about the drift velocity. The velocity in average that charges are moving through a certain conductor. So imagine we have a conductor and the conductor has charges that are moving, and we can define a certain area, transverse area. And the transverse area is the area of the conductor, the transverse area of the conductor. So if we imagine that the charges are going to be moving a certain distance x at a certain time, well, the drift velocity is going to be equal to the amount of distance that is going to be covered at a certain time. Of course, this is if we imagine that these guys are moving in a straight line, which they are not, for instance, but in average we can say that they are moving in a straight line. We remember from the past that the current is going to be equal to the amount of charges per unit time, and we're going to define a new variable which is called the charge density. This is the amount of charge per unit volume, and this is called, for instance, the charge density. So in this situation, the current is going to be the amount of charges, so this is going to be N times volume, this is the amount of charges, times the fundamental charge, over the time. The fundamental charge is due to we're imagining that electrons are moving, so this is going to be I, right? This is going to be the current. And since the volume is also the transverse area times delta x, remember we're coming from this kind of situation where we have a transverse area, delta x, and all of this is going to be the volume times now the fundamental charge over delta t. Given that delta x over delta t is the drift velocity, well, we can say that this is N times the transverse area times the drift velocity times E, being E, remember, the elementary charge, because we're working with electrons moving. So the current is going to be equal to NA drift velocity E, and the current density is this per unit area, so this is dN drift velocity E. And recall that, for instance, the volume, if we have, for instance, 1 mole of any element, well, that will have, for instance, Avogadro's number, which is 6.02 times 10 to the 23 electrons in 1 mole of any given substance. And also recall that 1 mole has a molar mass, or a mass as the molar mass, such that if we have the volume that is mass over density, we can have the density of any material, right? That will make the number of the charge density as Avogadro's number over the volume, which is mass over density, so we can put density here, right? So in this case the mass is going to be the molar mass of the substance that we're working with, and that will lead to a drift velocity as the current over N, which is, for instance, Avogadro's number, density, the molar mass can go upwards, times the elementary charge, since we're talking about electrons, times the area, or the current density times the molar mass times Avogadro's number times density times the elementary charge. So This is also a calculation for the drift velocity given all these parameters.